Welcome back to some more examples of sinusoidal functions as mathematical models. I will also have this up on Edline if you want to download this document. So let's just get right started on this. Okay, so what I've got here is I've got a population of some coyotes, and they've been tracked several years, and we are looking at a minimum value of the coyotes. It's so nice when they just tell you that, of 200. And we know when this minimum happened. We also have a maximum of 800, and we know exactly when that happened. So we're going to go through here and sketch a graph and write an equation and answer some questions about it. So let's see here. Let's do a little graph here. Not using a ruler. No, not using a ruler. La la la. Oh, looky there, I learned to draw straight. I actually used a sheet of paper, but whatever. Alright, so we've got time 2 equals 2.9, and then we have time t equals 5.9. Those are the 2 points they gave us. Minimum of 200, maximum of 800. There we go. And then of course we can see that it'll take 3 more years to get out to another minimum. So there we go. We've got a little graph here that would be this little cosine graph. And what we want to do is write the equation from here. So we can find our middle. Of course, the middle from there, 200 to 800, is 200 plus 800 divided by 2, or 500. I'm going to call this a negative cosine graph, so I'm going to focus my eyes right here at this 2.9200, and I will have y equals sinusoidal axis minus the amplitude. Why minus? It's minus the amplitude because I'm going to do a negative cosine graph. And I'm going to have this in radians, so I can see here that my period is this distance right here. And what is that distance? It's 6. So I've got cosine of 2 pi, remember 2 pi divided by our period is going to be our b. So I have 2 pi divided by 6 is b, which is pi over 3. Shifted over 2.9. Hopefully we're going to be doing this several days, and you're just going to bust through these. These are going to start to become second nature to you. So there's our graph, and there's our equation, and now we can answer some questions. Predict the population when t equals 7 years. So I want to find the function value at 7. And then I'll come back and do that. Let's go see that on a graph. I actually have that graphed here. I've got the equation. I'm going to turn off this second one. I want that on for now. Alright, so we just graph it. And I want to find a value at 7, so I'll go to second trace. I want a value at 7, and we can see that that is 622.021. So let's come back here and write that down. So that is equal to 622. We'll just round that to the nearest coyote because it doesn't make much sense to have part of a coyote. Alright, this next question says that coyotes are declared to be endangered anytime their population drops below 300. So the danger zone here is below this line, 300. You can probably tell why I had the graph of y equals 300 graphed earlier if you saw my calculator. So between what two non-negative values of t were coyotes first endangered? So I gotta find that from my graph, and I don't know because I didn't look there. I don't know if this is where this graph came up here. I need to finish that. I'm gonna get that all on my calculator. So let's go back to the calculator and let's graph the line y equals 300 and take a look. And I can see that it actually did come back up and hit 300. So I'll be looking at these 2 points right here. Between what two values of t were they first endangered? So I'll need to find those first 2 points. Let's see if I can do this correctly. So I want to calculate an intersection. And let me scoot over here closer to where I want to find it at. Alright, so that's going to be about right there, so I can just do first curve, second curve, my guess, and I got 2.096, which we can call that 2.097. So I'm going to come back to this and write on this 2.097. Is less than or equal to t, and then we just have to find that other intersection. So let's go back to this graph and look at that again. Find my second intersection, so I'll just do second trace, intersection, come down here, do enter, 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 and it looks like that second place was t equals 3.703. Come here and write that down. Okay, 3.703. So we've got the answers for C and D here, and again we're going to practice a lot of writing the equations from some data, and I want to take a look at one more that I don't know if I'm going to have time to finish in a 15-minute time period, but let's go take a look at it. Let me get a little bigger picture here. So I've got a tsunami caused by an underwater earthquake, and the water level at least basically acts like a sinusoid. It first goes down from its normal level, then rises an equal distance above the normal level. So let's take a look at this one. Alright, so I've got the period of this tsunami is 15 minutes, and it's got an amplitude of 10, and the normal depth of the water is 9 meters. So let's see if we can't. Here you see A, B, C, and D. I'm not asking for the equation, but I sure need that. So let's take a look at what's going on here. I've got the normal water level. Let's go down just a little bit. See, my paper does a pretty good job of making straight lines here. Pretty good job anyway. Alright, so I've got a normal water level of 9 feet. And I've got an amplitude of 10. So that means that the water is going to go 10 above that and 10 below. Okay, what else do I know? I know I've got a period of 15 minutes and that the water was at a normal level, but then it started off by first going down. And then so it starts off in the middle, and it takes a full 10 minutes to get back to the middle. Oh wait, not 10 minutes. That's 15 minutes later. It's a period of 15 minutes. The amplitude is what the 10 is. And so when is this going to reach its maximum? One thing that this is going to be almost a forced sine graph for us. So halfway between 0 and 15, 7.5 is going to come back here. And halfway between these two is when it's going to be down at a minimum and back to a maximum. This is really an instance where we need to write this as a sine graph. It's just going to be a lot easier. Now, I guess you can find this value in between 0 and 7.5, but I'm going to write this one as a negative sine graph. So let's write the equation. I'm going to have y equals sinusoidal axis minus the amplitude, and then I'm going to have 2 pi divided by 15, and then just x, not x minus anything because it's starting right there. And so there is my equation. So predict the depth of the water 2 minutes after, you just plug in 2. Predict the depth of the water 12 minutes after, you plug in 12. Let's answer the last two here. According to our model, what will the minimum depth of the water be? The minimum depth of the water is -1. And what does that mean for a depth to be -1? Well, if the depth is -1, that means there's no water on the bay at all. The water has gone back out somewhere, so it's nothing but sand. And then for how long will there be no water at the pier? Well, that's where we're going to have to calculate these 2 points right here. And you can calculate that intersection with your calculator. You're going to do a question like this tomorrow that's similar to a water level and something like that. And it's sort of weird, but you know, because you've got like a -1 water level, and what does that mean? But hopefully we're going to get a lot better at writing equations, because this is something we really need to practice on. So I will see you guys tomorrow.